Okay, everyone, it's Mr. Pettit here again. Today's lesson is going to be on present value, and we're going to be looking at that. So far, you guys have been working on future values, finding out the future amount and what it's going to be after you put in a lump sum of money and you let it sit for a few years or however long it is, and how it's compounded, and you're finding your future amount. Today, we're looking at our present value, which is also called our principal. Okay, so today what we're going to do is we're going to be given the final amount or future amount, and what you're going to need to do is find what you're going to have to put in today to get to that amount a certain length of time from now. So it could be, say for example, some examples could be tuitions for, say, college or anything in that format. So say, for instance, you need to have a college tuition. College tuition is at $6,000, and you need to figure out how much I need to put in today to come up with $6,000 in the time frame that I'm going to go to college. It could be a year from now, it could be 2, it could be 3, whatever it may be. But how much do I need to put in today to get to that $6,000 later on when I'm about to go into college? So I'm going to show you how to rearrange the formula. The formula was given A equals P 1 plus I to the exponent n. And again, A is my future amount, P is my principal or present value. 1 plus I, remember the I is in my decimal form, and my n is my number of years, and then after it's being compounded. So what we need to do is we need to find this right here. So this is going to be our method 1. So method 1 here is our first one. Okay, method 1 is isolating that variable. So to get rid of everything and just to make P by itself, I can just simply divide all of this by 1 plus I to the exponent n and do the exact same thing to the other side, which will allow me to see that I have P equaling A on the top all over 1 plus I to the exponent n. Okay, so there's my first method. There's my first method in showing you how to rearrange and to get P by itself. Okay, so putting the future amount that you know what you're going to have to get to in the future values. Same idea, the I, finding the I, dividing it by however it's compounded, and the n, multiplying it by however it's compounded. Okay. Method number 2. Method number 2, and I put a little star beside this because this is the method I prefer or I like, is A equaling P 1 plus I to the exponent n. Okay, so there's our formula from our original formula. So now what I'm going to do is I'm going to use something very similar to it, but it's going to go like this. It's going to go P equals A 1 plus I to the exponent negative n. So it's the negative n right there. So remember we talked about before with our exponents, with negative exponents, we just flipped the base. Well, the base is connected here. This is our base right here. If I use the negative n, it's just going to flip that, so it's going to resemble a 1 over 1 plus I to the exponent n. So that's what you're looking at. So if I have it something like this, 1 plus I to the exponent negative n, it's going to look like this, 1 over 1 plus I to the exponent n, which is very similar to what we just saw in the method before, and then we just simply add our a to it at the very top, and that's what it's going to look like. Okay, so our a is going to be our a times our 1, which is going to be just a by itself, and it's the same formula, but we're just using it in 2 different forms, 2 different methods. Okay, all right, so I'm going to go through the first example showing you the 2 methods, and then you can decide what method you would prefer when you're going through this. Okay, so the example is Jordan wants to invest enough money today to have $4,500 or $4,500 for college tuition in 2 years. If he invests at a rate of 3% per compounded monthly, how much does he have to invest? So we know so far that our A value is $4,500. Okay, we need to get to that in 2 years' time. Our I value is 0.03 divided by 12. And our n is 2 years times 12. and getting that. So I'll get our decimal form here, and we'll look at this. We'll type that in. So 0.03 divided by 12 gives you 0.0025. Okay? So using our method 1 formula, what we're going to do is we're going to take this and go I'll just write it out for you. 1 plus I to the exponent n, just like that. Okay? So we know A is $4,500. We know that our I value is 0.0025, so we're going to go 1.0025 to the exponent 24. Now, remember, this is a present value, so this value is going to be smaller than the 4,500. Okay, it's going to be smaller than that. So all I need to do is take my 4,500, divide it by bracket 1.0025 to the exponent 24, and I'm getting a value of 4,238.26. Okay? So there's our first formula, our first method that we're looking at in this case, and that's what we're seeing. Okay, so I'm going to show you the other method, and then what we'll do is we'll decide on the examples what to do here for those as well. Okay, so $4,238.26. I'm going to leave that number there because I'm going to show you that both these values are going to be the exact same. 0.0025. My n value is 2 times 12, which is 24. Now, if I'm going to use my other method, which was A in brackets 1 plus I to the exponent negative n, we'll look at that. So 4,500, 1.0025 to the exponent negative 24. Okay, so again, when we're looking for present value, we're going to use the negative exponent. If we're going to look for the first method, we're just going to keep it as a positive, but it's going to be something that's underneath as a denominator. So sometimes what I like to do here is I type in the bracket first and the exponent and then multiply it by 4,500. So 1.0025 to the exponent negative 24 equals, the decimal that you see on the screen is going to be less than 1. Multiply that by 4,500 and you get the exact same answer, 4238.26. So they both equal the same. So either method, either one you choose is fine. Okay, is okay. All right. Looking at our examples. So looking at the examples, and we'll see exactly what we have here. And again, remember, this is amounts of money that we need today. Okay, what do I need to do? How much money do I need today to figure out how much I'm going to have to earn or invest, or how much is going to take to get to that amount later on? Okay, example number 2. It says, how much money should Jessica's parents invest on her 12th birthday if they wish to have $12,000 when she turns 19 if the interest rate is 4.8% compounded quarterly? Well, remember, first off, when we're talking about years, that's some of the things we're looking at. A is $12,000. This is our future amount, what we want. We want this as our 19th birthday. She wants to have $12,000. I is going to be 0.048 divided by 4, which is going to be 0.012. And again, just 4 divided by 4 is 1. 8 divided by 4 is 2. Get that? Our n value is going to be 19. First off, we're going to have to figure out how many years it's going to take. So it's going to be 7 years. 7 times 4 equals 28. Okay? So I'm going to show you the method here. I'm going to show you one of the methods, and then you can decide which one, again, you can look for and go from there. So I'm going to look at my second method. Remember, I told you I like that method, but I'm going to show you the other method in the one next, in the next question. So 12,000, 1.012 to the exponent negative 28. And P is going to be, so again, I type in that, 1.012 to the exponent negative 28 equals, times that by 12,000, and I'm looking at 8,592.65. Okay, round to 2 decimal places, always with money, always with your dollar amounts. So this is what I need to have on her 12th birthday. Jessica's parents are going to have that, either bring it to the bank or wherever they're going to invest it in. But that's how much money they need to invest for 7 years, compounded quarterly at 4.8%, to get $12,000 on her 19th birthday. Okay, so that's the whole format here, and that's what the definition is in that case right there. How much do I need today to earn that amount later on in the time frame? So that was example number 2. All right, now let's take a look at example number 3. And look at this. This is a 2-part question for number 3. It says, Amber invested $3,000 for 5 years at a rate of 4% per year compounded semi-annually. How much interest did she earn in the first year? So, in the first year, how much interest did she earn in the first year? This is just a simple question that you're looking at. This is just this is not even a present value or a present value question. She's invested this already, so she wants to know the interest rate she earned in the first year. So this is my present value because that's an investment that she earned, that she put in, $3,000, and I is at 4%. Compounded semi-annually, so it's 0.02, and my end value is just going to be simply the first year. So 1 times 2 is 2. So the future amount that I have here is $3,000. She's investing that and putting it in here. So this is not a present value question, but it's asking you the interest, going back to some of the interest questions that we looked at yesterday or the day before. So A equals, and again, we look at this first year, so 1.02 to the exponent 2, times that by 3,000, and it's $3,121.20. Well, how much interest did she earn in the first year? Well, remember, interest is my future value minus my present value. So 3121.20 minus 3,000 equals $121.20. Okay, so that's how much she earned in the first year. Now we got to go back to the second part here, and now we got to figure out how much she earned altogether. How much interest did she earn altogether? So that was for the first year. Now we're going to figure out how much she's going to earn in the 5 years. So 5 times 2 equals 10. We're looking at 3,000, 1.02 to the exponent 10. And now we're going to figure out how much she is earned in the 5-year time. To the exponent 10, multiply that by 3,000, and it's $3,656.98. So take this number, subtract it by her 3,000, and we're looking at 656.98 she made as her interest in the 5-year time. Okay, so that is our format that we're looking at. Now what I'd like you guys to do is work on the practice questions on the very back. Again, when you're looking for present values, make sure you're looking for what do I need today to get to that particular amount later on in life, okay, or later on in the time frame that you're looking at. Okay, so good luck with those questions. If you have any problems, shoot me an email, and maybe we can go through a Google Meet or go through some of those questions as well. All right, talk to you later.